Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. I actually have a good idea. I don't know why it just comes to my mind now. But for changes like this, we have the perfect tool, I think, to verify that nothing would go wrong. And we worked on this a couple months ago. If you may remember, you may watched my developments towards tooling for Thyme. We worked on this beautiful tool called unassemblize, right? So let me open this guy. Unassemblize solution, yeah. It was production ready, I think. Yeah. So what we need to do is we build a release build. Yeah. Let's do a full rebuild. Yeah. Clean build. Yeah. And then let's put it somewhere where we can find it. So I guess we build here release, right? No? x64 release? No? Where will it dump the files? Huh? Here? Let's wait. Let's wait until it's done. Yeah, I think that's a good idea. Yeah. Oh, fails. Why do we have fails? What? Oh, that's not good. That's not good at all. Configuring incomplete. What? Let me see. Unassemblize. Develop. Yeah. Fetch and prune all remotes. What is this here? Compilation database. Exits. Hold on one moment. Okay. Okay. Yeah, I don't know why we have compile errors here. That's unexpected. But okay, let's let it run through and then we compile once more. Maybe then it just magically works. Yeah, maybe not. Mm-hmm. Okay. Now there's some errors. Yeah. Well, let me run it again. Well, that succeeded. No idea why it failed on the first time. Probably some misconfiguration somewhere. Okay, anyway, it succeeded. So we have the tool here, unassemblize.exe. Okay, how about we take this guy and we put it here into our projects, super hackers, generals tools. Generals tools. Generals tools. There I like to dump my tools for generals. Unassemblize. Unassemblize. Let's go by date. Date is let's go by a hash. How about that? Paste. Let me open a command prompt. cmd cd unassemblize minus help. Oh. Oh. GUI. Okay. There we go. R243. Let's rename it. R243 3A707 to 6. 707 to 6. Yeah. Then let's add a let's add a CMake lists. No, git ignore imgui dot ini. And then we should probably add in a subfolder. How about we name the folder that, and we change the executable name back to that, and then we move it in here. There we go. I think that's better. Good. Then we run this with GUI. cd unassemblize minus GUI. Okay. And then in here, so we put this here on the side. Yeah. Put the file manager here. Yeah. Okay. And then what we do now is we open another command prompt. We go to a general's game code. We take Mauler's change here. Hold on. The fixed loops index warnings. And then we go to one before that here. Check out this commit. There we go. Then we have this command prompt. Then we go to We go to here, we close this. We go to here, CMake builds. We punch this here into our command line and this guy and this guy. We only build 0 hour. 0 hour, 0 hour, yeah, only 0 hour, okay. And then we build that guy. I think we can remove this line here, by the way. Yeah. Configuring done. Yeah, generate done. And now we build, and then we need to wait a little bit, but it shouldn't be too bad. Actually, I have a very good idea that I think I have a good idea that lets us avoid testing such changes. Avoids. Hold on, we are building release. I hope you get symbols. Patience. What is a good idea? Patience. Yeah, so we need to wait a bit. In the meantime, we can probably check out what's new here. Oof. Oof. Let's see. The channel's version waits for uint max milliseconds. The general's version waits for uint 32 max milliseconds. Huh? Where? Well, it's infinite. Well, I think infinite actually means infinite. I think infinite actually stands for infinite. It makes no sense to time out a lock, a mutex like this, and then still go ahead and run the code that is supposed to be locked. Typically, timeouts should bail out, not proceed. It makes no sense to time out a mutex like this and then still go ahead and run the code that is supposed to be logged. Typically, timeout should bail out. Typically, a timeout should bail out. I suspect the easiest, I think the proper fix here is to get to I think the fix here is to delete the scoped mutex and simply use a critical section for the locking. Okay, so what about the compilation is still busy? Yeah. Okay, so what we do then, we go to our build folder here, build, vs6, there we go. And then generals md, yeah. And then generals exe, this one. Yeah. Okay, we need to wait until it's done. No. Okay, and then what we do is we take this hash name here to see where is it. Copy to clipboard, commit hash. Can we take this short hash here? Commit hash. Still compiling. Okay, actually we should make a folder. Take this commit hash. We do have release, right? Let me double check that. Release. So yeah, release of 0 hour on, off, default, yeah. Okay, so this looks good. Let's check that. Check it. Yeah, it has just built. Very good. It also has a PDB file. Excellent. Then we take this guy and we put it in here. Now we go ahead to the last change here, this one. We do a checkout. Can I actually just check out this one here? Okay, and then we build again. Yeah. So basically we will have one compilation for before the change and one after the change. And then we load that in unassemblize and we do a diff on the executable code. And the code is expected to be 100% identical. That's my expectation. If there's a difference, then it will be interesting to see what it is, right? Actually, this is would also be a cool thing to test for with things that incur we know that, for example, when we upgraded the 0-hour object vectors to the object hash map in the GameLogic class, that it incurred a mismatch to the retail game. It would be interesting to see like what actually is different in the executable. I think we need to run it once more because it didn't actually link. So it would be interesting to see what the actual diff is, right? Yeah. Mm-hmm. Mm-hmm. Okay, now it has linked it. Okay, excellent. Then we take that hash. Yeah. Where are we? Here. And then we put in this guy. Okay, there we go. Okay, we have it prepared. Now we go here to unassemblize, add file, 2 files. We browse to the program here. We go to the super hackers, generals game code, oops, builds, vs6, generals MD. And so this is the right side is the previous. There we go. We select this guy, okay. And then here, let me pick here the folder, browse. Oh boy, the browsing is not ideal. MD, where are we? Huh? Let me make this larger. Generals game codes, builds, vc6, generals, MD, and this guy, right? This guy. Okay. So these should be different executables. Yeah. All right. And then we do a compare. And process matched and unmatched functions. Compare. And it doesn't work. Oh boy. Why not? Huh. Oh, that's too bad. Why does it not work? Revision 1. Revision 2. File 2. Ah, okay, hold on. Compare all. Okay, that didn't work as well. Okay, but the files are loaded. There are the symbols. There's not many symbols though. Huh? Oh, that's unexpected. That is unexpected. Okay. Okay, I'm a bit surprised that I'm a bit surprised that we don't see anything here. Huh. Oh, that's interesting. Why is this not working? Looks like we need to debug this now. Yeah. Yeah. Did it load the PDB? Oh, we don't have a config. We don't have a config. But we don't need one. We don't need a config. PDB file config. Evaluates to. It doesn't say that auto evaluates to anything. Why not? PDB. Do I have to explicitly give it this name? There we go, super hackers. Projects. Oops. Documents. Build. Why does it look for a JSON? PDB config file. Oh. I see. I see. Hold on. I first have to remember how to use this tool, actually, even though I'm the author of it. Okay, that means I didn't make it very intuitive. Build vs6 generals MD. Here, we have to select the PDB, but not here, in the other field. Here, and then here we type auto. Evaluates when the PDB file is read. Yeah. Okay, and here we do the same. We take this guy, we put it here. We do PDB. So basically everything is auto. And now we can load it. And there we go. We can also load this guy. Yeah. Okay, so that has loaded PDB and executable, and now we have 43,000 symbols. Excellent. Most excellent. Okay, and then we can do we can compare file 1 with file 2, compare, and it should now be 100% match. And it's not. Okay. Let's go with a single bundle. Single bundle, single bundle. There we go. Compare. Okay. Oof. It's not the same. Let's do these guys, the offsets. The offsets we can do match strictness lenient. There we go. Match strictness lenient. There we go. Okay. And that means, why don't we see a number here? Oh. There's some mismatches. Chat AI updates. There were some mismatches. Oh shit, it crashed. Oh, holy shit. Oh, that's not good. What happened? Okay, let's let me launch the tool here in debug. Yeah. Let me compile it in debug. That's unexpected. I didn't expect it to crash. Well, what are all these warnings here? Jesus Christ. Something is going totally wrong here with the compilation. Jesus Christ. Man, what is wrong with this thing? Jesus Christ. Jesus Christ. Let me stop this bullshit. I don't understand what's going on here. That's really some bullshit. Why is this so screwing up? The assembly armada. Unassemblize. Unassemblize. Dot solution. VS 2022. Okay. Configure. Generate. Okay, let's try that again. Okay, that worked normally now. Interesting. Good. Let's run this guy. Set a startup project. Let me check the command line arguments here. I think we do. All configurations. I think we can go ahead with this guy. We put this in here, and then we do GUI. So we take this guy. This guy, generals ZH, generals ZH PDB, and then the other one is this guy. I hope that works correctly. It's a bit hard to read. Generals zh.pdb. Okay, let's see if that works. Basically, it should fill. It should automatically fill out here those files for us. Yeah. Yeah. Yeah, looks good. Ah, hold on. I'm not sure if that works. Maybe it does. Okay, let me remove this here. There we go. There we go. And debug, it takes quite a bit longer to load that shit. Jesus Christ. Wow, debug error. Holy shit. Okay. Okay, it must be an assert. Oh. Okay. Read symbols. PDB reader, read symbols. Edit. size, reserve size, index I, smaller size, auto edit, false, function address to index map, try and place. Oof. Oof, oof, oof. Oof. What is this bullshit? Size 10. CEE60. CEE60 already exists. How? Well, that's a shame. So there is a function that has duplicate name, or what is the problem here? CE60, there we are. So AV particular system template. Decorated name, undecorated name, decorated name. Let me open this in the watch. Watch. Let me clean up here. No. Watch. Good. So, no, that's not the right one. Functions place. There we go. Good. So, this guy and this guy. Okay, what's the difference here? So they start at the same, they have the same address. The name is also the same. Yeah. Name is the same. Global name, but the release buffer. That's strange. I don't quite understand what this is here. Somehow ASCII string release buffer and the destructor of ASCII string have the same symbol name here. Why? And the same address. They're one and the same thing. Okay. Well, in that case, maybe we need to remove this assert here. edit. Let me remove this assert. Okay, let's try this again. Compare. There's another one. Retry. What is this? Oof. Leave. What? Dang. Dang. What is this bullshit? Huh. Throw. Why throw? What? Oh boy. Okay, that is unexpected. Is that related to the size? No. Why is this failing here? Message. Move. Move. Throw if exists. Throw if exists. Throw. Logger is name. Huh? Register logger. That actually exits the program. What the hell? What? Okay, oh, that is wild. Let me just load one file to begin with. Why is this failing suddenly? Okay, that has worked now. I wonder if there's like a race condition when loading two executables at the same time that take about the same time to load. Yeah. Maybe. That's a shame. Okay, that has loaded successfully. Now let's do a comparison. And that also fails. What is the error here? Okay. Begin address is smaller end address. Oof. Well, that's not true. Begin address is smaller end address. It's the exact same. Huh. Disassemble function, named function, FLT used. Okay, so that function has no size. Begin address, end address. Interesting. Okay. Set address range. Well, then I guess what we do here is if begin address equals end address, then return. How about that? Done. I guess we will again get a different assert somewhere where it will complain about instructions being empty. Maybe. We will see. Because now this function won't have any instructions. Yeah. Okay, well, a lot of problems here. Yeah. Loads. Loads. Okay. Let's try again. Error. Retry. Is disassembled. Get instructions. It's not expected to be empty, yeah? is disassembled. Or let me see, function, so it's the same, right? Yeah. Or we say get instructions. Or we say that or function get begin address equals function get end address. Yeah. Yeah, let's try that. I'm worried that we will crash then somewhere else, and then somewhere else, and so on. Yeah. It's not the fastest. No. I think reading the PDB takes so much time. Yeah. Okay. Oof. Oof. Wordlen is not 0. Oh boy. Text. Text is empty. Oh boy. Ah. Wordlen is 0. C. Word begin. Oh man, what is this bullshit? Text is empty. Wordlen. Why is this empty? What is this? M instructions. Size 14. Instructions 14. Huh? 14 instructions. 14 F 15 I 15 20 20 15 this guy. Text is empty. Huh? Is jump is invalid. Oh. Huh. It's invalid. What the hell? Huh. Okay. It's invalid. Huh. Okay. It's invalid. There's a knob, red. Aha, it's behind the red. Oof. Oof. What kind of function is this? Function pair. Do we see? Do we see what this is? Matched function indices. We can't see what it is. Matched functions. Oof. Let me put that into the watch. Ugh. Can we dot data plus I get is that possible? Yeah. Huh. How do we access this guy? Oh boy. We can't access span. Oh, we don't have I see. We don't have oh shit. We don't have a nutvis for this, that's why you cannot access it here. Yeah. Storage PTR maybe. Dot storage dot PTR. Oof. Oh, I don't know how I can access this now. Oh boy. Oh boy. Call stack, split instruction text. Okay, so there's an invalid instruction somewhere. Yeah. How do we deal with this? I think the root problem here is that the function claims to be larger than it really is. Yeah. How do we solve that? Yeah, I think there's a problem higher up than this. This seems weird. Function address. Ah, shit. Yeah, we get unmatched sizes, I guess. Oh man. Let me go back to this guy here. Yeah, this is a real problem, isn't it? Let me do if not added, int a equals 0. Put a breakpoint. Shit. No, I originally tested it against like a small build that we had. Yeah, it's the first time that we run it against a PDB with so many functions, and yeah, of course there's still issues. That's too bad. Yeah, that's too bad. Maybe we can fix it. Maybe not. Okay, so we have a hit here. Good. So I10. Yeah, this works. Size 10. Size 10. Size 10. Yeah. Functions. Okay. So what is the length of these guys? Let me see. Lengths 27, 27. Okay, that's good. Let me see other cases of this. Let me open a functions I and I minus 1. Huh? Something is not right here. The decorated name claims to be this, but the undecorated name is something completely different. What? What? Something is not right here. I don't understand. Let's see some more examples. Scan real, scan string. What? RAM file reads. Okay, that makes sense. That also makes sense. Okay, but why do they have the same address? Why do these things have the same address? I don't understand. Line number. Let me close this. Let me make this larger. Okay, so source file ID is the same. Compilant ID also the same. Length is different. Decorated name different. This one different. Global name is different. Source lines also different. But the address is the same? No. Why is it failing then? How? If not added, why is this failing then? Address, apps virtual. The address is different. Huh? Ah, maybe it's colliding with another one. Hold on. This one here. Right, let me take this symbol here. Second. So I think we are looking at functions dot second. There we go. Oh, that doesn't work. Why not? 2e. Why is this not working? Functions. Maybe it's a pointer. Yeah, it's a pointer. Okay. Okay, so this. Right, RAM file. Length is the same. Okay. Huh. What is this bullshit though? Okay, how about we do the following? If it cannot add, if it cannot add, then we expect that so functions so the first function is this guy and the other so we have pdb function info, right? Good. So pdb function info, let's call it this function, and then other function, and that goes here. Iterator it second, yeah, and then we do const, and we put assert this function dot length equals other function dot length, and then this function dot source lines dot size equals others dot size. There. Assert, can we anything else? This function. Decorated name, global name. I guess the decorated name should match, right? Yeah, other function dot decorated name should match. Yeah. Let's see if that would hold true, or if we get an assert hit there. Let's see. Let's see. Load. Yeah. I mean, as long as the decorated function is the same, we don't care about the other guys. They can, yeah. We don't care. It's, yeah. Yeah. Or do we? Okay, it has loaded. Who's building this guy? Read symbols. Read symbols. Okay, I mean, where's this used? What is this used for? Is this used by anything? Find function by address. Build source lines for function. Okay. It seems to be fine then. Okay. Okay, but we get more errors, so it's not good. Yeah. Okay, so we press compare here. Okay, that didn't fail. Yeah. View match strictness lenient. Okay, so what do we have here? Conflict. 2 visible items with conflicting ID. Oof. Okay, we go to single bundle, all. That gives us again the mighty error. Oof. Oof. Okay, so there's some invalid. Yeah. How does that happen? Shit. I really would like to know which functions causes this exactly. Begin address, end address. Yeah. Ooh. Who's doing this here? Which function? Matched functions is a vector. I think we need a not this for shit. We need a not this for span. Ugh. there should be a type somewhere. Types. Span. I think it's called TCB span. TCB span. Let me search for using span. There we go. Common type span. Okay. How about we search for TCB span not with. Not with. There's no. TCB span. Not this. There's no information on not this here. C++ 98 compatibility. Wow. Nice. TCB span. Let me ask ChatGPT, maybe he has one in store. Can you write me a NatVis for TCB span? A NatVis for TCB span. Let's see if ChatGPT understands this question. Oh, he does. Well, that was simple. Well, the question is if that works. Size. Okay, looks like he understands, but this assumes the internal structure of span is something like that. But it's not like that, right? Let me look. Oh, shit. Let's open span.hpp. TCB span here. There we go. And somehow it didn't jump in there, and there we are. Okay. Storage. Oof. Storage type. Oof. I don't know. Well, that's one complicated storage type. PTR size. Okay, let me extract this. Notepad. Span storage. Okay. Storage type. Okay, let me. Oof. Okay, so detail. Span. Let's say namespace TCB. And here we close other namespace. Okay. Let me delete all this. Here. Storage type. Element type. Extend. Okay, so this is the simplification. Span storage, element type. Yeah. Okay, let me pass this to here. The storage looks like so. The span storage looks like so. Let's see. Thanks. Okay. Detail span storage size. Is that correct though? I don't think that's correct. Or is it? Maybe it is correct. Let's try this then. So unassemblize resources. Not this. And span dot not this. Okay. And then we do what we do here. Here it's subdirectory resources. Let me go to here, game code resources, Visual Studio. Let me copy this guy. Let me do the same name here, Visual Studio. Put that in here. Edit. Span, not this. Let's call it TCB span. TCB span. All right. Okay. TCB span. Okay. Then we go here to CMake list and we do, oh boy. Here include Add library resources. Interface resources. Is this being referenced anywhere? Resources. Let me see. Oof. CMake lists. CMake lists.txt. Add subdirectory. Okay, that's all. Okay. Okay, let's just add subdirectory resources here. Okay. And then we do configure. Let's stop debugging here. Yeah. Generates. Okay. Okay, and the resources exist now here? Yeah, it does. Okay. Okay. And then we do... then we do... compile. Yeah. Let's see if we see anything now. Yeah. Let's see. Good. So load and load. Too bad it doesn't work out of the box. Yeah. Yeah. Maybe we can get it to work. If not, yeah, then we don't use it. But considering we build it, we should be able to fix it up. Right? There's probably not many errors. Yeah. Yeah, maybe. Maybe there are. Man, it takes so long. Oof. Oof. Let's close this. Okay, retry. Good. So, can we see now this stuff? Here. Good. So basically, we want to see this guy here. in the watch. It doesn't work. Shit. That's too bad. Yeah, it doesn't work. Okay, so whatever ChatGPT has given us doesn't work. Yeah, that's too bad. Yeah. Okay, what could be wrong here? Value pointer. Storage. Huh? Storage PTR. Yeah. Size. Something is missing there. I wonder if yeah. Type name TCB spun. Display string size. Detail span size. It looks kind of correct. Name. Maybe we need this prefix here, like this. Auto visualizer. Yeah. Maybe. Let me ask ChatGPT. Does this XML not need the auto visualizer tags? If you're placing this in standalone NetVis file or embedding it directly, you need the outer. Yeah, thank you very much. Thank you very much for your tips. Why does he put 5 now here? Why he puts 5 here now? Replace 5 with the appropriate extent. Huh? Dynamic extents. Yeah. Yes. Please give me. Oof. Okay. Poof. Let's test this first. See if that works. I hope it does. Will it be enough to just can it hot reload it, or or not. Visual Studio reload NatVis. Tools options, debugging, output window, NatVis diagnostic messages, C++ only, yeah. Verbose, yeah. Observe the output windows for NatVis errors. Yeah. Let's see. Output. Okay, how do we refresh this now? Debug. Watch. I mean, it's already a great start. It looks already pretty promising, but the question is, how do we get the final run here? Ugh. Do I need to restart the program now, or can it hot load it, or how does it work? I remember I did it in the past, but it has been a couple of years already. I think there is a way where you can like reload it, or it's auto reloaded. I don't know. Maybe if we just like save it here, maybe it will reload it. Build, debug. It doesn't tell us here anything. Observe the output window. Where's the output window? This is the output window, but which option here? Build order, debug, build. No. Hot reload? No. I don't know. Okay, let me just restart the session. Unfortunately, I have no clue. I have no clue how to see. How to see if there's success. I think there was something like, there was I do remember there was an output and you could see like when this loaded if there were any errors in the format or so. It would tell you, but I maybe here? Diagnostics hub, maybe here. Let me ask ChatGPT, how can I debug the NutVis in Visual Studio 2022? Can be a bit tricky. Use the debugger, visualizer test case. Debugger visualizer to verbose. Debugger visualizer. Debugger visualizer. What is that? Debug visualizer. Huh? Debug Windows output. What? Output window. Huh? Go to Tools, Options, Debugging. Options, Debugging. Yeah. Output window. Yeah, there we are. Set debugger visualizer. Well, that doesn't exist. It's not a good tip here. Yeah. Storage.size. Oh, no, I'm comparing it against itself. Oops. Retry. Yeah. Good, let me change to here. Watch. So for some reason this... Yeah, okay, so it still doesn't work. Storage PTR size. Storage PTR size. How about we do storage dot size. Aha, there we go. That works. Cool. Okay, cool. Now we can properly debug this bullshit. Then what we can do now is we go to call stack. Here we put this guy into the watch. There we go. And now we can see, oof. Well, it doesn't have much. What does this refer to? Matched functions. matched functions. Named index pair. Right. Okay, so named functions matched function indices named index pair named functions pair. Huh? Okay, so I think what we need to do is dial, oh boy, dot functions pair. What is this? It's an array, right? Yeah, it's an array. Okay, so what we do is 0, oh my gosh, 0 and then 0, oh boy. Array named functions 2 named functions points to an array, to a vector. Ugh. 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 Man, what is this bullshit? 0, 0. Okay. Size. Okay, good. 0. We need to dereference it. Okay, like this. Okay. Okay, so we dereference it like this, and then we index it with here 0x3EEF, right? There we go. Okay, so the function is currently ferrying supplies, and that has a begin address and an end address, instructions 14. Yeah. Yeah. Okay, and for some reason this function is currently ferrying supplies as an invalid instruction. Why? Okay, let me get that that name. Let's okay, how do we want to avoid it? We could say if it's an invalid instruction, then don't split it up, right? Yeah. Yeah. We say if instructions I dot is invalid, if not is invalid, then we do this. Yeah. Let's see if that helps. Let's see. Then the question is, why does it go beyond? Why does it go beyond? So the problem, just judging by the instruction that we saw earlier, it read past the return instruction, right? And that's why there's like some invalid behind us, some nops and whatever is behind the return, right? That's why this thing screws up. But why is the size bigger then? That's not good. It's not good at all. Okay, compare. Let's see what kind of error we get now, if any. Okay, so the name was is currently ferrying supplies. Yeah. Is currently ferrying supplies. And there's another error. Oh boy. Instructions is 0. Yeah, okay. Instructions are empty. Run comparison. Function pair. It's that function with the 0 address. Yeah. Run comparison. Is compared. Yeah. Okay, how about we say is compared, matched function. Pairs a function from 2 executables that can be matched. Yeah. Okay, run comparison. We have a bit of a problem. It expects that the sizes are not 0, but what if they are? Split instruction texts. Will this work with 0 arrays? Arrays, resize. Okay, this could be 0. What happens if it's 0? Reserve 0. Counts. Comparison records. Maybe we can remove these 2 here. Yeah. Let me see. Maybe there's a follow-up crash, but it looks like this logic should also work if if one instruction is 0. Right? It looks like it would work. Yeah. I could be wrong. I've been overly cautious when I wrote this. I placed a lot of asserts to, make sure that logic would be within the expected boundaries. But maybe some of the checks are not necessary. Yeah. We will see. If it crashes, then yeah, that needs adapting. Bad. Oh, bad. Yeah. Yeah. Man, the loading is so slow. Okay, it finished without errors, so that's good. Let me go to single bundle. For some reason, it doesn't show all. It doesn't show a number for all. Why not? Lenient. Aha, that's an error. Aha. Okay. Let me see. Assert. Distance has value. Okay. Okay. Instruction is jump. Null opt. Get distance. Assert has value. Okay, so this fails because we have invalid instructions at the bottom. Yeah. Okay, so the problem we have is that somehow some functions report to be longer than they actually are, right? For some reason. Can we find out why that is? Can we find out why? I mean, we already have here this one, right? How about... How about we place in the PDB reader, we place a check in read publics, read globals. I need some water. Okay. So there should be a function somewhere where we read publics. Oh, public symbol, decorated name. Is that a function? Where do we reach the functions? Oh boy. M functions. Here. Build function, read symbols. Read symbols, reserve. Function. Here, read compilant function. Read compilant function. Undecorated name. There we go. Okay, so how about we say find lines. Get length here. I mean, if the length is reported to be what we get here, then I don't see what we can do against that. Yeah. Okay, let me ask you a different question. Can a x86 let me just open a new chat. I am using DR2. Is it DR2? Yeah, DR2. I'm using DR2 on Windows to read PDB files. Some function symbols some function symbols report a length that goes beyond the last return into that let's say that leads beyond the last return. of the function assembler. It's beyond the last return of the function assembler. What could be the problem? Observe that a function assembler report length leads beyond the last ret or other terminating instruction. PDB length values often include entire address ranges covered by the function, which may contain epilogues. Okay. Include padding. Okay. In 3, yeah. Have cold code or exception handling landing pads that are not in the main instruction path. Try disassembling with a linear sweep from the function start to the reported end address and check for int3 knob. Aha, that's a good idea, yeah. That's a good idea, yeah. We could stop at int3 on knobs. Yeah. 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 That we would do in, oh boy. That we would do in, we would do that in where? That's the wrong solution. It would have to be in ASM. Oof. AS. I forgot. Executable function, right? Function. Yeah, here. Disassemble, yeah. And then we would say instruction count. Instruction index. Instruction count. Yeah. Then we would say then we say if ASM instruction address set bytes is symbol true, instruction index status. Yeah. Okay. Science status. ASM instruction, was it this thing? Address, line number. No, I think instruction index. I think we have to add a check here. Here, somewhere here. here. Behind this one. Inside this, how can we check the instruction for int3 one up? Check instruction. Instruction mnemonic. Okay. Okay, then we put here if instruction mnemonic instruction. Oh, that's a different instruction. Hold on. Instruction mnemonic. Zydus decoded instruction. This is a disassembled instruction. How do we get the decoded one? Here, instruction, decoded instruction. Instruction info. Instruction.info.mnemonic. There we go. Okay, equals that, or it is complaining still. If that or nope, then we break. Yeah. Function may contain epilogue, padding, compiler inserted helper instructions, or exception handling landing pads, cold code, or exception handling landing pad. I don't even know what that means. Epilogue, no idea. Padding, okay. Helper, I have no idea. I don't know what cold code means. Exception handling, landing pad, I have no idea. Sounds good though. Function may contain epilogue, padding, compiler inserted helper instruction. Let's say function end. Yeah. Stop. Yeah. Okay. Instruction mnemonic, blah, blah, blah. Okay. Looks good. Break. Okay. Let's put a breakpoint in here. And then we would need to put the same breakpoint down here. Here. Yeah. Just realized that Clang format is turned off here. Yeah. Break. Okay, let's see. Stop debugging. There. Okay, that would be great if we can get rid of this bullshit. Yeah. Then that would help. Yeah, that would help a lot. Okay, let's see, load. Yeah. It's not hitting. Please, please, please. It's not hitting. Ah, it didn't reach that stage yet. Okay. Oh, it did. Shit. Well, hold on. No, it only read the PDB. Right. It only does it when we do the comparison, actually. Yeah. Hold your horses. Hold your horses. Yeah. Man. Going really scientific here. Yeah. Yeah. Man, this thing is slow. Okay, compare. There we go. Okay, so let's see if that ever hits. There we go. It is hit. Nope. Nope, nope, nope. For what function is it hit? Let's see. Disassemble function, name function. Okay. 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 Nope. So this happens where? Yeah. Instruction count is 195. Okay, so it is already quite advanced. 405 instructions. Yeah. And how much is left there? 525188 of B4B C56. It's not so much stuff, no? Where did it start? Begin address C5E0. CC56. Yeah, so it went through the majority of bytes, so it's probably justified that it hits something there. Yeah. Okay, and so it breaks out. Instruction count matches this. Okay, this is good. Yeah, this looks good. Fantastic. Fantastico. Okay, let's see. Okay. And then let's visit this function here, or any other. Basically, any function that has not 100% match, right? Yeah. Let's see. Single bundle. Okay, so let's set that to lenient. Okay, let's try to find something that is not 100%, like this one here. There we go. Okay, I'm scared. I'm scared. Uh-oh. Uh-oh. Oh. 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 Interesting. Oh. shit. Okay, so there is a return here, but there's still something behind it. Shit. Okay, what is behind it? Instruction. Okay, it claims there's a short, there's a jump. Instruction. Instruction. Can we see the instruction, please? Name function. Function. Instructions. Yeah. Oh boy. Oh shit. Okay, let's put that in the watch. Named function. Okay, so function instructions, scroll down. There we go. Okay, so what do we have? Yeah. Push RD. There's a return. Okay, and after the return comes some instruction. Oof. Ah, looks like a jump table maybe. Yeah. Jump table. Let me ask. Can a x68 assembler can a x86 assembler function contain multiple return statements instructions? Yes. Oof. Absolutely, he says. Okay. Okay, so the question is, how do we know that behind that we should ignore this guy? Oh man. Jump short. Jump length 15. Okay, how can we ignore the jump tables? How can we do that? Well, we could check if it's jumping outside. Where's it jumping? 15. So this one is jumping 15 bytes, 15 hex. 15 bytes, yeah. No, 15 hex bytes, yeah. which is behind this, basically. Yeah. Yeah. Let me ask, how can we detect a jump table behind a function return? It's tricky, but very doable. Jump. Typically just point past. Look inside the function for an instruction like jump table or that. Then trace the jump table address. You can also use DIA to find the syntax label or syntax thunk. Zydus mnemonic jump. Okay, this doesn't help. This doesn't help. No. Look inside the function for instruction like that. Jump. Jump. Oh. Yes. Give me some snippets, yeah. Is likely code address, analyze function. Okay, find the last red. Oh, we can find the last return. That we can do. We can, how about we keep track of all returns, and then if there's anything past the last return, we cut that off, right? Yeah, that could work. How do we do that? How do we do that? Let me see. That could work, yeah. Let's go back to function. Function here. So we say if instruction count. Okay, how about we do let's do First of all, let's go back in here and we comment out this check here. So we get an early assert. Yeah. Good. So that's step number 1. Okay. So we need to keep track of all the returns. Let's do I have an idea. We do what is this here? Size t. Size t. Last instruction. Last return. Last return instruction index 0. Okay, and then we say here we say if mnemonic is return, yeah, then we do last red instruction index. We do this equals this, right? Actually, let me take this out. Yeah. So, but it will still. I think it's fine. Just let it run over there. Okay. Okay. Let's hold on. Let's move this down here. Let's comment this out. Okay. So if this return, then we set to instruction index. Good. So instruction index. Instruction index. Instruction. Instruction index. Does it have to be before or after this increment? Instruction index. I think it has to be before. Yeah. Okay, let me. Yeah, I think that's a okay place here. Okay. Okay, and then we say and place back. Yeah. And then what we simply do here, instructions, we say if instruction, if last read instruction is smaller than instruction count, then we decrease the size, resize, resized that. Return resize +1, right? Cut off any instructions behind the last return. Let's say function may end with epilogue padding compiler inserted helper instruction cold code exception handling landing pads or jump tables. Cut off any instructions behind the last return. Okay, let's put a breakpoint in here. Let's see if that hits. Yeah. Okay, so basically we would still read all the instructions and we would append them, but then we would cut them off at the end. Because we only really know... hold on. We know the last return from here already. Hold on. Instruction count. Okay, what we do is, hold on, I have a better idea. We take this guy. We take this guy. We take this. Instruction count, last index, last return instruction index. Okay, and then here we do reserve. We change the instruction count to this +1. Let's put a breakpoint here, which in most cases should be identical. Yeah. Okay. Okay, okay. And then here we can remove this now. Okay. And then we can also remove this here. Okay, we remove this. That's more elegant. And then we put the comment here. Function may end, cut off any instruction by the last return. Yeah. Yeah, that's more elegant. Let's compile this guy. Yeah. Load. Okay. Oh boy. Oh boy. Oh boy. Maybe that works. That would be great. But what if this function doesn't end on a return? It could also end with a jump, right? Yeah. That's okay. We go case by case, right? Yeah. Okay, good. So now this guy F, yeah. So basically, the instruction, the return is the last instruction. So that's why this will just equate to the same, right? Yeah. Let me put a breakpoint for condition. Yeah, we don't need to breakpoint on it. Let's just assume it works and let's see what happens. Oh shit. Okay. What happened? Instruction index. Oof. Oh, right. Oh. Right, it doesn't go by this. Right. Instruction index. We still need to early exit. Ugh. We also need to change the end, right? Section offset end. Section offset end. Yeah. It's const. Oh. Okay. Let's do we need to change this one here as well. Yeah. Or what we could also do, while instruction index is smaller than that we could also do. Yeah. Section offset. Yeah. Section offset. Section offset. Section offset end. Section offset. Okay, so we do need to reset these two. Okay, but what we can do is we can do while this smaller, while this smaller than this, that we can do. Yeah. Yeah. That should work. Let's see. Maybe. Let's see. Load. Okay, let's see. Please, please work. Please. Yeah. Maybe. Please. Oh. Retry. Oh boy. Okay, so we still have cases where it's not quite right. Let me see why. Instructions. Oof. Okay, instructions. Watch. Instructions. Let's take a look at these guys. Yeah. Let's look for the small one here. That's not a return. Let's check this one here. That's also not a return. Nope. That's a return. Okay. And then the next one is what? Oh, that looks like a jump table thingy. It's invalid, true. Okay, so here we have a return. But for some reason, it didn't work. It didn't work somehow. Why? Why does it not work? It didn't hit this one. Right, because of this. Huh. Instruction count. Last return instruction index. +1. What if... We should probably change this to 0u if last instruction is not 0u. Okay, but that doesn't explain this problem. Why is this a problem here still? Do we have a return? We have a return. But we still have stuff behind it. Why? Why? That makes no sense. Oh, because there's another return here. Oh. Shit. Oh, oh, well, that sucks. Okay, how do we deal with that? There's another return at the very end. And it has some weird number here. Shit. Yeah. Fuck. Last red offset. Find the last return. Yeah, but that doesn't work. That doesn't work. So jump land. Okay, it jumps back. Oof. Okay, here we have an invalid instruction. What you can also do is we can also say if it's an invalid instruction, then we return or break. Yeah, we could do that. Put that here. Yeah. We could also say if we could say if Zion success, and then if that, else break. Is that fair? Break. If Zeit is calc absolute address, then this should never be true. Yeah. Zion, if not Zion success. Okay. We abort mission, and if it wants to jump outside this range, then we also abort mission. Yeah. Let's see if this ever hits here. Oh boy. Oh boy. Yeah. Good. Compare. Okay, we do actually hit that. Look at that. Okay. So we have a, let me see. Oof. Instruction count. Oof. Well, I don't think that this is intent here. No. No. Okay, what if we, let's not break, let's see. Maybe it's enough to have an invalid Here, I'm not sure. Probably not. Oh man. Try and error here. It's not nice. Not nice. Good. Compare. Let's see what we get. Oh man. This is not good. Okay, at least it doesn't error now. Okay, well, we still have things that don't quite match. Let's put it to lenient. Let's scroll. Let's find something that is not 100%. There was something. There. Get boer. Let's see. Let's scroll carefully. Okay, there's a return. Okay, so there's the last return, and then we have another instruction here. LEA. And then there's another return. How can we detect this shit? It's kind of weird, isn't it? There's this random garbage here, so to say. Yeah. It's just random bytes, really. I wonder if the bytes are always consistent. Like this 8D4900. Let's see if that's a repeating pattern. Countermeasures behavior. Oh, that has changed. That was actually touched. Yeah. That was a function that was touched, and that's different now. Very different. Let's see this one. I think we need a filter for functions that filter out. Okay, fuck. Oh man. Now this tool is not production ready here. Jesus Christ. Yeah. Yeah, okay, I think I will take a break here. Maybe we look a bit more next session. Yeah, but I will end it here. Good, then I wish you a great day or night until next time. Goodbye.